Alright, in this video, this is the trimmed down version of one of my TEAS live math sessions that I held in my Facebook group. You can find a link to that Facebook group in the description below, but I did want to share this with those of you who are on YouTube, who watch my TEAS math tutorials, and you have not joined my Facebook group. Go ahead and do that now. Now, sorry about the quality of this video. I forgot to actually record the screen itself, so I had to re-download the live session from Facebook. And the max resolution there is 720p. So sorry about the quality, but nonetheless, it should be clear enough, both the audio and the video, for you to follow along. Without further ado, let's go ahead and look at that live feed. The topic for tonight is equations with fractions. I want to show you a few techniques in terms of solving these. Sorry and let me mute that. So anyway, this first example here, I want to motivate some ideas that I do see a lot of students do. And when they're dealing with fractions, sometimes they want to convert those to decimals. And there's absolutely nothing wrong with doing that as long as you get nice decimals. Let's look at this example here. We have x minus 3/4 equals 5/2. Now, if I take that fraction 3/4, we can do 3 divided by 4 and we get 0.75. So let's think 75 cents. And then we have this 5/2. If we take 5 divided by 2, notice we get 2.5. So I'm going to rewrite this and I'm going to say x minus 0.75 is equal to 2.5. This is the exact same problem, except I have converted these fractions to decimals. And that's totally fine, as long as you get nice decimals. So here, I want you to think about money. Let me just rewrite this. Suppose we have some money amount, subtract 75 cents, and if we subtract 75 cents from something, we get $2.50. Well, let's think about that. If you had $3.25, let's just think about that for a second. If you had $3.25 and you subtract 75 cents from that, what are you going to get? You're going to get $2.50, right? That is our answer. But later on in this mini session that we're doing tonight, we're going to see sometimes that these decimals are not going to be nice. But if we did want to solve this, let's add 75 cents to both sides. And when we do that, we get x is equal to, and if we take 250 and we add 75 cents to it, we get the $3.25. Now, the only downside to this is that if you did this on the TEAS test, more than likely that answer is going to be given to you in fraction form. So this is how I want to motivate the idea of tonight's mini session. I want to take this exact same problem and I want to solve it a different way. And this way that I'm getting ready to show you will always work when you have equations with fractions. So, if we look at this, when you have an equations with fractions, what I want you to think about. So, equations with fractions. When you have that, let's multiply everything by a common denominator. Now, trust me, when these fractions get ugly and when our decimals get ugly, this is a good way to approach it. So if we look at our denominators, we have a 4 and a 2. Now some of you may be thinking 8, some of you may be thinking 4, some of you may be thinking 12. All of those are valid common denominators. So I'll tell you what I'm going to do. I'm going to multiply everything by 4 because it actually turns out that the least common denominator is equal to 4. Therefore, if I take this and I multiply everything on the left-hand side by 4, and I multiply everything on the right-hand side by 4. Now you may wonder, why in the world am I doing this? Just wait. Let's distribute this 4. 4 times x, we get 4x. Let's take the 4 and distribute it to this negative 3/4. And remember, the way that you can multiply fractions, technically 4 is the same thing as 4 over 1. And if we take 4 times this 3, we get 12. Just don't forget your minus here. And then if we take 1 times 4, we get 4. Over on the right-hand side, let's do the same thing. Essentially, you're taking top times top, bottom times bottom. So if we think about this as being 4 over 1, 4 times 5, we get 20. And then 1 times 2, we get 2. So how does this clean up? I mean, what are we really doing here? First of all, the 4x, nothing wrong with that. Check this out now in blue. If we take 12 over 4, which is the same thing as 12 divided by 4, that's going to be 3. 12 divided by 4 is 3. And over here on the right-hand side, if we take 20 divided by 2, we get 10. Notice now, when we had an equation with fractions, when we multiply everything by a common denominator, we actually have an equation now that is very nice. We don't have any fractions. So let's solve this. Let's add 3 to both sides, trying to get x by itself. We have 4x is equal to 13. And then if we take 13 and we divide it by 4, because we're trying to get x by itself, we get an answer of x equals 13 over 4. Grab your calculator real quick and recall our decimal answer was $3.25. Well, if I take 13 and divide it by 4, notice we get $3.25. Same exact answer, except we're taking a different approach. And this is how I pretty much tackle every single problem with equations that have fractions in it. So with that said, let's take another example. And yes, this one could be done with converting to decimals. We could take 1 divided by 4. We could take 3 divided by 8. So instead of doing that, since I see an equation with fractions, I'm going to use that same idea. When you have equations with fractions, multiply everything by a common denominator. So let's do that. Look at your denominators here. We have a 4, we have an 8, and you may say, oh, what about this one? Well, that's an understood one. We have to multiply everything by a common denominator. And some of you may be thinking, oh, why don't we combine like terms? Sure, if you want to, do that right now. However, I'm not going to because I'm trying to get rid of these fractions. A common denominator here, the best one to pick would be 8 because that's the least common denominator. Could you pick 16? Yeah, because 4 goes into 16, 8 goes into 16. Could you pick 32? Could you pick 24? Yes, but 8's the best one to pick. It's the smallest number. So I'm going to multiply both sides by 8. So repeating that process again. Top times top. 8 times 1, we get 8. Leave that 4 alone. Again, that's because really we're taking 1 times 4. So we have 8 over 4p. Now take your 8 times this 3. Just watch your signs here. So 8 times 3, that gives us 24. Don't forget your minus. This is over 8. Same idea here. 8 times 3. 1 times 8, top times top, bottom times bottom. Let's not forget our p. And this is now going to be equal to, be careful here, 8 times 4, 32. Now you may say this still looks messy, but the whole point of us multiplying by a common denominator, we get whole numbers now. We get nice, pretty numbers. 8 divided by 4, we get 2p. Minus 24 divided by 8, we get 3p, and this is equal to 32. Let's combine like terms now. Had you combined like terms up here, totally fine, but now, in my opinion, it's a lot easier to combine like terms here. So 2p minus 3p, we get negative 1p, and this is equal to 32. And just remember, you want to get p completely by itself. We want to get rid of this negative 1, so we can divide both sides by negative 1, and therefore we get p is equal to a negative 32. That is our final answer for this problem. Now, something I want to show you here as well. As you are practicing these problems, I would encourage you to check your work. You cannot really do that for every single equation on the TEAS test because you'll run out of time. But watch what I'm going to do here. I'll grab my calculator. And we said our answer is negative 32. So I'm going to use my calculator to help, but I'm not going to be able to fully check everything on the calculator because we don't have a negative key on the TEAS calculator, not to my knowledge. Maybe you do, maybe you don't, but let's not worry about that. So if we go back to our original problem up here, we're taking 1/4 times our answer. 1/4 times our answer. So if I take 1/4, 1 divide 4, that's that 0.25. If we multiply that by P, which is negative 32. Now, again, assuming we don't have a negative button, I'm just going to multiply by 32, and I'm going to press enter. Now, make sure you're paying attention here. Really, we're taking 1/4 times a negative 32. So technically, this is negative 8. Let me scribble that down. Then we have minus, scribbling that down. Back to the calculator. Now we're taking 3/8 times our answer. So 3/8, 3 divide 8. We get a decimal. That's not an ugly decimal. Times P. So technically this is times a negative 32, but I'm just going to multiply by 32 here. And notice we get 12. But remember, we are multiplying 3/8 times a negative 32. So this will be minus a negative 12. And if we work this out, watching our signs here, negative 8 minus a negative, that becomes a plus. What do we get? Negative 8 plus 12, that is equal to 4. Check it out. It matches our answer. And that's really the whole point of an equation, is to find a value for the variable that makes this equation true. Now, these last two problems we have done, technically, like I said, these are nice fractions because they turn into nice decimals. But sometimes that's not the case. Okay, let's look at this one right here. We have this fraction over here, and then we have this fraction right here, 5/6. Well, you might not want to jump the gun and necessarily convert these things, to decimals, or maybe we don't want to multiply by a common denominator at the very beginning. Here's what I mean. Let's use a distributive property. Multiplying this, and I'll tell you why I'm doing this right here in a second. But if we go ahead and multiply this, top times top, watch your signs. We have a negative times a positive. So 3 times 8, we get 24. 4 times a understood 1, we get 4. And remember, let's watch our signs. A negative times a positive, we have a negative. And let's not forget our x. So there's our distributive property on the first one. Let's do it on this one as well. Watch your signs. A negative times a negative, that is a positive. So don't always just bring this thing down. What I recommend doing actually is to look at what you're multiplying. You're taking a negative times a negative. That's why I wrote a positive here. So let's do top times top. 3 times 12, that gives us 36. Bottom times bottom, that gives us 4. And let's move over here to the right-hand side. You may say, oh my goodness, we got fractions everywhere. This is going to work out nice. Watch what happens. So, top times top, we have a positive times a positive. 5 times 6 is 30. Over bottom times bottom, 6 times 1 gives us 6. Do not forget your x. Repeating this one more time. Top times top, 5 times 12, we get 60. Bottom times bottom, we get 6. Now, I have not talked about common denominators yet in this problem, because sometimes you don't have to. Look at how nice these work out. 24 divided by 4, we get 6. So we have negative 6x. Hang on one second, my son's right here. What's up, buddy? About 10 more minutes. Yeah, I'm home alone with my son right now. But anyway, back to here. Where was I? So 24 divided by 4, we get negative 6x. This will be, now look at this, 36 divided by 4 plus 9. And this is going to be equal to 30 divided by 6. That gives us 5. So we have 5x. And then we have plus 10. Look at how nice this worked out, and we never had to talk about a common denominator. Sometimes this happens. And the reason why I'm doing this with y'all is because I don't want you to always assume, oh, Mr. Kraft said if I have an equation with fractions, I got to find a common denominator and multiply by it. If you look over the problem and you realize that some of these things are going to work out nice, then you can actually dodge that step. Let's finish this off. I'm going to move, and it doesn't matter which one you move, I'm going to move the 6x over to the right-hand side. And I like doing that because it keeps my coefficients, it keeps my answer, or not my answer per se, but it keeps this positive. So I got rid of my x on the left-hand side. Nothing wrong with that. We're left with 9. That's a positive 9 is equal to 11x plus 10. And then from here, our x is on the right-hand side. So I'm going to get rid of everything else over here, moving the 10 first. Subtracting that, that will cancel out our 10s. And 9 minus 10, watch your signs. If you have $9 in the bank and you wrote a check for $10, you're going to overdraft by $1. So 9 minus 10 is -1. This is equal to 11x. And then finally divide both sides by 11. So therefore, our answer is -1 over 11 is equal to x. And sometimes you will get funky answers like this. You have to trust your work. And the more you practice these equations, the more you're going to become comfortable with that first answer that you get. And that is kind of crucial, since the TEAS is timed. This last one here, here's the strategy I want y'all to take. Start by distributing first, then multiply everything by a common denominator. I'm going to distribute first. Go ahead and get rid of my parentheses. So 1/3 times r. Now remember, this is an understood 1 in front of that r. And anything times 1 is itself. So 1/3 times r is simply going to be 1/3 r. Now we can take that idea of taking top times top, bottom times bottom. 1 times 6, we get 6. 3 times 1, we get 3. And let's repeat this process on the right-hand side. So 1 over 6 times r, well, 1/6 times r is 1/6 r. And now, okay, well, let me draw my arrows. Distributing here, top times top, bottom times bottom. 1 times 8 is 8. 6 times 1 is 6. Now, there's a couple of things we could do here. Does anybody notice that we could actually simplify this fraction? Now, if you didn't notice that, don't worry about it. It's fine. That's the beauty of math. You can overlook certain steps in a problem and you'll still end up with the same answer. And probably out of the 30 of y'all that are watching right now, I'm guessing at least half of you probably didn't even think about simplifying that. So I'm going to take that approach. I'm going to act like I did not notice that I could simplify this. So what I'm going to do is I see an equation and I got fractions all over the place. Maybe some of you didn't notice this either. 6 divided by 3, we can actually say 2 there. But let's act like you didn't notice that. It's fine. Look at all of your denominators. A common denominator that we can multiply by is 6. Could you have picked 12? Yes, because 3 goes into 12. 6 goes into 12. Could you have picked 18? Absolutely. But the least common denominator is 6. So I tell you what I'm going to do. I'm going to multiply both sides by 6, and I'm going to use the beauty of technology here because I'm a little lazy. Let's distribute here. Top times top, bottom times bottom. So 6 times 1, we get 6. 1 times 3, we get 3. Don't forget your r. Top times top, bottom times bottom. 6 times 6, we get 36. And this will be positive since we're multiplying positive numbers. Bottom times bottom. 1 times 3, we get 3. This is equal to, carrying on over here, top times top. That's going to be 6. Bottom times bottom. That's also 6. Don't forget your r. One more time. Top times top. 6 times 8. This will be a positive answer. We have 48. And then bottom times bottom, we have 6. There's several things that we did not, or I'm acting like we did not see. I'm acting like we did not see that this could be 2. I'm acting like we did not see that this could be simplified. Totally fine. Totally fine. Watch what happens. 6 divided by 3, 2r. Plus 36 divided by 3, that's 12. Equals 6 divided by 6 is 1. That's an understood 1r. I'm just going to say r because that's understood to be 1R. And then we have plus what? 48 divided by 6, we get 8. Look at how nice that looks. Even though we had ugly decimals, 1/3, that's a repeating decimal. 1/6, that's a repeating decimal. Last but not least, I'm going to get well, not last but not least, but let's move the R's over. I'm going to move that R over here. R minus R, see you later. 2R minus 1R, well, 2 minus 1 gives us 1R, but I tell you what, let's leave it like that. Plus 12, this is equal to 8. And then finally, we have one more step to get the R by itself. Let's subtract that 12. This will give us R completely by itself, and we get R equals -4. All right, ladies, and I think we had a couple of gents. I hope y'all have a good weekend. Tag me with any questions in the group, and I will see y'all later. Have a good night.